Good evening, everyone. So let me first share my screen. Am I audible to all? Please confirm. Please somebody confirm. Am I audible? Anyone? Okay.
Yes, ma'am.
So what we will be discussing about we will be discussing today is that last time we were doing the convergence of backward Euler method, and we did not able to complete that proof. So I will try to complete that proof first, and then we'll move towards the stability of the forward Euler and the backward Euler method, and later we will see some questions based on forward and backward Euler. We will try to complete this backward and forward Euler method. Okay, so I'm going to continue from the last line. I'm writing it down here. En is less than equals to e raised to power, or I can write it as exponential of 2hl mod en minus 1 plus twice of truncation error th, right? So this was the last line. इसके बाद में we were trying to find out the convergence of this error. This error is not actually diverging, but it is converging. So for that, let me see who is trying to join. तो यहाँ तक सबको क्लियर होगा कि हम लोग हमने यहाँ तक तो इस प्रूफ को कंप्लीट कर लिया था, ठीक है? इसके आगे का कंटिन्यू करेंगे एंड विल ट्राई टू शो द कन्वर्जेंस ऑफ बैकवर्ड आइलर मेथड. जिसने भी क्लास अटेंड करी थी, आई एम श्योर दे ऑल नो हाउ दिस इक्वेशन हैज डिराइव्ड. ठीक है? अब इसके बाद what we did in the last class, we tried to put different values of n starting with n equals to 1, 2, 3, 4 and so on. And then this whole equation is converted into a particular form that En is less than equals to exponential of 2hl whole power n modulus of E naught plus n times of exponential of 2hl 2hl whole power n minus 1 into, this is into twice of mod of th. अब उस टाइम पे we were discussing that how this equation has derived. तो कुछ बच्चों ने बहुत अच्छे से बताया भी था कि मैम we can do this thing or that thing. So I'll try to first explain that how this equation is coming. ठीक है? Okay. So now I'm substituting n equals to 1, 2, 3 and so on. And what I get from here is that if I put n equals to 1, then I get E1 is less than equals to exponential of, this is the thing that I have to prove. Okay? If I put n equals to 1, then mod E1 is less than equals to exponential of 2hl mod E naught plus twice of pH. If I put n equals to 2, then E2 less than equals to exponential of 2hl mod E1 plus twice of mod of th. And Also, I can write it down, this E1 in terms of E naught by substituting this inequality here. So exponential of 2HL bracket exponential of 2HL mod of E naught plus twice of mod TH bracket close plus this whole bracket has done plus twice of mod of TH, right? And similarly, if we do up to En, let me try to open this again. I'm writing the same equation here. Here I'm multiplying this exponential of 2HL inside this bracket. So I get exponential of 2HL whole power 2 mod E naught plus twice of exponential of 2HL mod of TH plus twice of mod of TH, right? So let us try to find out for n equals to 3 also. इससे थोड़ा सा और clear हो जाए equality. So E3 is less than equals to, what was the equation? बहुत late join कर रहे हैं बच्चे. Where he has gone? So E3 is less than equals to exponential of 2HL mod E2 plus twice of mod of TH. And E3, if I write it directly, I'm substituting the inequality of E2 from above, and the whole equation is again converted in the form of E naught. Not equation, inequality is converted into form of E naught. So I can write it directly as exponential of 2HL whole cube, like here square has come, so here cube will come, mod E naught plus twice of mod of TH exponential of 2HL whole square plus twice of mod TH exponential of 2HL plus twice of mod of TH. So if I repeat the same process up to nth time, then finally I get mod of En is less than equals to exponential of 2HL whole power n mod E naught. I'm taking twice of mod of TH as common, and the term is coming as exponential of, like, if you look at this inequality, so the terms are coming as 2 and 1. The power here, the power of exponential of 2HL is 2 and 1 for n equals to 3, right? And now I'm writing it down for n equals to n, then the power will come from power will start from n minus 1, n minus 2, and so on power 1. Are you getting my point? That for n equals to 3, the power starts with 2. So in general, if I'm writing the same inequality for n equals to n, power start with n minus 1, right? So exponential of 2h L whole power n minus 1 plus exponential of 2HL whole power n minus 2 and so on up to, if I'm adding this term also, because I have taken this 2 mod th as common, so I can write down it as exponential of 2HL plus 1, right? किसी को कुछ भी प्रॉब्लम हो तो प्लीज पूछ लेना कि how this equation is coming. Are you please confirm somebody, are you getting my point that how this inequality is coming, how I have taken this 2 mod h as common and the remaining terms are here. Is it okay for all?
Yes, ma'am.
Okay, so mod en is, I'm not converting it in inequality. Yeah. It is equals to exponential of 2hl whole power n mod e naught plus twice of mod th. This is mod. Okay. And I can write down what I'm doing here. I'm replacing every term. Like, as this is an exponential term, so the power will come into the multiplication, right? And what is it? Positive exponential, it is the positive exponential because all the term 2hl are positive. H is the step size, L is the total length of the interval. So all quantities are positive. So as n increasing, this वैल्यू इज ऑल्सो इंक्रीजिंग, क्योंकि एक्सपोनेंशियल का ग्राफ तो हमेशा x की वैल्यू इंक्रीज होने पर e की पावर x की वैल्यू भी बढ़ती जाती है. सो इफ आई एम रिप्लेसिंग द एवरी टर्म बाय दिस टर्म, आई एम रिप्लेसिंग एवरी टर्म by this particular exponential of 2hl raised to power n minus 1, then how many terms are here? N start with 1 to n minus 1. So there are n terms. So n times of exponential of 2hl whole power n minus 1, right? So this was the term, this was the inequality that we were trying to prove in the last class, but maybe there were some calculation mistake or I don't know what was the problem. So this was the final equation that is coming out here. But yeah, we have to made a few changes also. Somebody was trying to join. Yeah. Now I can also write this equation as exp 2hl n, right? I'm taking this power into this multiplication into mod e naught plus twice of mod th n times of exponential of twice of n minus 1 hl, close bracket. Okay. So now what we will do, we can also write this term as n times of 2n mod, since 2n mod th exp of twice of n minus 1 hl is it is less than equals to twice of n mod, this is n, th exponential of 2 nhl, right? Because this is, here the power is n minus 1 and this side the power is n. So that is why I can write it down. This value is less than this. And also what I can do, I can multiply and divided it by h. So it can be written as 2nh exponential of, everything I'm doing is to just find out the particular inequality for the convergence. This is just a simple calculation. So 2nhl into mod of th divided upon h. I have multiplied and divided this term by h, and this nh become tn. Why? Because tn is basically t naught plus nh. And what I have taken t naught I have taken 0. T naught is the initial time. Did you remember that what equation I have taken? I have taken this equation. I'm writing this rough portion here. dy by dt is equals to f of t comma y, or maybe I think I have wrote down it is in a capital U, I guess, or capital Y. So this is capital Y for the exact solution. And the initial condition I have taken as y at t naught as y naught. And right, so here I have not mentioned the value of t naught, no? You can understand this, like I have just mentioning the simple notation here. This nh makes tn. Why? Nh means like h is the partition of the particular interval. Suppose this is 0 and 0 to 1 interval, and I'm partitioning it into 3 parts, 1 by 3, 1 by 3, and 1 by 3. So h is 1 by 3 and n is my total number. This is just a notation that I'm replacing this nh by tn, and this nh is also replaced by tn. So if twice of tn exponential of twice of tn capital L mod th divided upon h. So what we have done here, we have showed that since this value is less than or equals to this term, so in that above equation, here here I can replace the whole term with the this term. So finally I get from here that En is less than equals to exponential of twice of Tn capital L mod of E naught plus capital is small h will come. No, small h is already here. So 2 Tn exponential of 2 Tn capital L mod Th divided upon h, right? And now what we will do, we will substitute the value of th. What was th? Th is equals to 1 upon 2 h square capital U double dash, or let's not capital U, y double dash of epsilon n. Epsilon n is less than Tn minus Tn plus 1 and Tn. Epsilon lies between Tn minus 1 and Tn. Did you remember this? We have written with the help of Taylor series expansion. The last time we have mentioned it as the last term as mentioned by Th, and it is 1 upon 2 h square y double dash of epsilon. Now, I'm if capital M is the bound of this y double dash of epsilon n, if capital M is the maximum of y double dash of epsilon n, where epsilon n lies between this, so I can write it down it as En is less than equals to exponential of 2L Tn. I have taken this as common, mod E naught plus capital M H Tn, because there is also H in the denominator. So this H and this H will cancel out. So only one H is remaining, and M is the bound of this y double dash of epsilon, and this 2 is cancelled out with this 2 and into Tn, right? And since E naught is what? E naught is capital Y at T naught minus small y at T naught. And we know that both of these equal by the initial condition. That is why its value is 0. So this E naught becomes 0. But En is less than equals to exponential of 2L Tn capital M H Tn. So for fix Tn equals to T star, for a fixed time T, and for n is equals to also n is also keeping fixed as capital N, I get E mod En is less than equals to exponential of 2L T star M T star into H. So I'm writing this whole term as capital C. So mod En is less than equals to capital C times of H. This is the condition for the convergence of backward Euler method, right? Because this is, or obviously this is the equation, this is the definition of convergence, that our error is not actually diverging, it is converging towards a fixed direction. So किसी भी स्टेप में कोई भी प्रॉब्लम है कि मैंने Tn कैसे लिखा, या फिर कोई भी स्टेप में आपको कुछ समझ ना आया हो तो एक बार पूछ लो, ठीक है? ये मैंने लास्ट क्लास में कहा था कि आई विल सेंड यू द प्रॉपर द नोट्स दैट आई हैव रिटन माय नोटबुक. सो मैंने इसलिए नहीं भेजा, आई थॉट यू वुड ट्राई, ठीक है? तो मैं आज आपको ये जो डेरिवेशन है बैकवर्ड आइलर के कन्वर्जेंस का, तो मैं आपको आपके सीआर को मैं फॉरवर्ड कर दूंगी एंड शील सेंड इट टू द ग्रुप, ठीक है? क्वेश्चंस जो होंगे जितने भी असाइनमेंट के, दैट आई विल नॉट पोस्ट, आई विल डू इट इन द क्लास ओनली. बट जो डेरिवेशन टाइप कुछ होगा तो वो मैं उसका पर्टिकुलर फोटो क्लिक करके वो मैं आपको पीडीएफ आपको ग्रुप पे शेयर करवा दूंगी, ठीक है? किसी कोई प्रॉब्लम नहीं है? नेक्स्ट विल मूव टुवर्ड्स द स्टेबिलिटी ऑफ द फॉरवर्ड एंड द बैकवर्ड आइलर मेथड. So to check the stability, uh, we we take this initial value problem, which is y dash is equals to lambda y, or capital Y. And the initial condition is taken as y at t naught is equals to capital Y naught. So whenever, if you want to check the stability of any method, you always try to find out the solution by this initial value problem. Like यहाँ पे हम लोग आइलर कर रहे हैं, तो इस पर हम आइलर अप्लाई करेंगे. अगर आपको आर के मैथड अप्लाई करना है या टेलर सीरीज से चेक करना है whether the particular method is stable or not, so we'll always use this type of initial value problem. So इस टाइप की इनिशियल वैल्यू प्रॉब्लम से चेक करेंगे कि क्या फॉरवर्ड और बैकवर्ड आइलर मेथड स्टेबिलिटी प्रोवाइड करता है या नहीं करता है. if it gives the stability, then under what conditions the particular forward or backward eiler is forward and backward eiler method is stable. कि मैम ने आपको बताया भी होगा कि फॉरवर्ड आइलर मेथड इज कंडीशनली स्टेबल बट बैकवर्ड इज अनकंडीशनली स्टेबल. So there will be some condition in forward so that the given method is stable, but there is no such condition in backward Euler method. That means backward Euler method is always stable. There is no such condition which makes it as unstable. It is always stable, but there are some condition in forward which makes it stable. So which one is better? Obviously backward Euler method is stable. Backward Euler method is better comparative to the forward. But होता ये कि backward Euler में थोड़ा सा calculation wise थोड़ा सा complicated हो जाता है. Because उसमें जो equations derive होती है, those are non-linear type. Not separated explicitly. These are implicit equations. तो उसको solve करने के लिए we try to use some other methods also. We will see in some assignment question that how we will do a particular how we will solve a initial value problem using backward Euler method, जिसमें हमें कोई और method की भी requirement होगी to get the initial point. Right? तो computational wise या फिर mathematically forward Euler method को करना easy रहता है compared to backward, but backward gives more stability of the solution of given problem. So let us see. So first we will do the forward Euler. So what is the forward Euler and what is lambda here? Let us suppose lambda is any complex number. I'm not taking it as a real number. I'm taking it as a complex number. So what will be the choice of this lambda which makes this initial value problem as a stable, or I can say it is a bounded, right? So what is in general its solution? The solution is e raised to power minus lambda t, I guess. Like it comes in the form of this, not minus, it is plus. I'm not writing it the correct solution, but it comes into this form of, when we solve in general this 1D this ordinary differential equation. So first order ordinary differential equation, then we get this type of solution. And for what value of lambda this solution is convergent? Obviously lambda should be negative. अगर lambda positive हो गया and lambda goes to infinite, solution goes to infinite, तो उस केस में solution की stability loss हो गई. There is no stability of the solution. Stability का meaning ये हुआ कि there must be some bounds so that the solution is bounded by that particular number or the particular bound, right? In that case, we say the solution is stable. So in case of forward Euler method, this is the rough form. हम ये भी देखेंगे कि लैम्डा की किस वैल्यू के लिए हमारे पास स्टेबिलिटी मिल रही है एंड अंडर व्हाट कंडीशन, एक्स्ट्रा कंडीशन वी विल गेट द स्टेबिलिटी. So what is the forward Euler? It is y of n plus 1 is equals to y times of f of tn comma yn. And what is f tn comma yn? It is yn plus h times of lambda of yn. I'm picking up this yn as common, 1 plus h lambda. And now y lambda. So yn plus 1 is equals to 1 plus h lambda times of yn. Now I'm again substituting n is equals to 0, 1, 2, 3 and so on, so that I can convert this nth term in terms of y naught. So I can write it as y n plus 1 is equals to 1 plus h lambda whole power n plus 1 into y naught. Right? I can write it down in terms of this. For n equals to 1, we get 1 power. For n equals to 0, we get the power 1. N equals to 2, we get the power 2 into y naught. For n plus 1, we get the power n plus 1 into y naught. Now, अब देखो, this is a fixed value which is already given in the initial value, initial condition, right? So इसकी वैल्यू अब क्या फाइनाइट होगी, तभी हम कहेंगे कि हमारा जो सोल्यूशन है एज डिफरेंट डिफरेंट स्टेप्स पर, स्टेप्स का मतलब n की different iteration कह लो, कि for different iteration our solution should converge or not converge, our solution should be bounded. So अगर ये वाली वैल्यू हमारी फाइनाइट होगी ना हर n के corresponding, only in that case we get a stability of the solution. So under what value of this the given solution gives the stability, that the solution is stable if this modulus of 1 plus h lambda should be less than or equals to 1, right? अगर ये हमारा 1 से बड़ा हो गया, ये पावर के जो अंदर वाला टर्म है 1 से बड़ा हो गया, तो n की वैल्यू जितनी बढ़ाते जाओगे ये सॉल्यूशन बढ़ता जाएगा, कोई एक फाइनाइट एक बाउंड मिल ही नहीं पाएगा जिससे ये जो हमारा गिवन सॉल्यूशन है वो एक स्टेबिलिटी प्रोवाइड करे. तो it is necessary that this 1 plus h lambda, modulus of 1 plus h lambda should be less than 1, or I can write it down as 1 plus h lambda should be less than 1, equals to 1 and greater than equals to minus 1. Also, h lambda should be less than equals to 0 and greater than equals to minus 2. Right? I'm replacing this 1 towards the right side and the left side. So h, not lambda, this h should be less than, if I am writing this h here, so this h should be less than minus 2 upon greater than, 2 upon lambda. It is greater than 1. H lambda is less than 0, and if I am writing it in the denominator, it should be greater than equals to lambda. Right? So let us first see here that ये 1 plus h lambda जो है वो lambda की किस वैल्यू के लिए 1 या 1 से छोटा कोई नंबर प्रोवाइड कराएगा. ठीक है, तो लैम्डा शुड बी नेगेटिव ऑलवेज, क्योंकि लैम्डा अगर पॉजिटिव है, एच तो हमारे पास हमेशा पॉजिटिव होगा ही, क्योंकि एच तो हमारा स्टेप साइज है, स्टेप साइज इज ऑलवेज पॉजिटिव. लैम्डा को या तो 0 होना पड़ेगा या नेगेटिव होना पड़ेगा, तो लैम्डा शुड बी नेगेटिव. ओनली इन दैट केस we will get this 1 plus h lambda is less than equals to 1. तो लैम्डा की यहाँ पे अपन को एक बाउंड मिल गया कि लैम्डा जो है वो हमारे पास कॉम्प्लेक्स नंबर से बिलोंग कर रहा था, राइट? So the real part of lambda should be less than 0. ठीक है, या फिर हम अगर real भी consider करें, so lambda should be negative only in that case this 1 plus h lambda modulus is less than equals to 1. ठीक है, और यहाँ पे देखो h का एक बाउंड दे दिया कि अगर मेरे पास h is greater than equals to minus 2 upon lambda हुआ, only in that case our method is stable, the forward Euler method is stable. अब अपन चेक करेंगे क्या ऐसी कंडीशन जो है कि this method is stable if this holds, the given solution is stable if this holds. तो अब अपन backward के लिए भी चेक करेंगे कि is there any condition in backward Euler so which makes the given method stable. तो उसमें अपन देखते हैं कि there is no such condition on any variable or any h which makes it as unstable, कि h की कोई भी वैल्यू ले लो that backward Euler is always stable. तो अपन एक बार बैकवर्ड आइलर के लिए देखते हैं. फॉरवर्ड आइलर का आई गेस आपको सबको समझ में आ गया होगा. तो एक बार बैकवर्ड आइलर मेथड या बैकवर्ड आइलर फॉर्मूला अप्लाई करके वी विल सी द सेम प्रोसेस टू चेक द स्टेबिलिटी. तो व्हाट इज बैकवर्ड आइलर फॉर्मूला? Backward Euler formula is y of n plus 1 is equals to yn plus h times of f of tn plus 1 comma y of n plus 1, right? And what is this? This will become y of n plus h times of lambda of y of n plus 1, right? So अब यहाँ पे y of n plus 1 इसको मैं left side transfer करूंगी and finally I get it as 1 upon 1 minus h lambda, because left side लेके जाऊंगी and then we will get the factor 1 minus h lambda, and when I'm transferring it into the right side it comes into in the denominator into y. ठीक है, so we will get this equation. Same process that we will substitute the value of n equals to 0, 1, 2 and so on. We get yn plus 1 is equals to 1 upon 1 minus h lambda whole power n plus 1 y naught. ठीक है, अब अपन चेक करेंगे under what values of this term the given solution is stable. So the method or the solution is stable if this 1 upon 1 minus h lambda or also I can write mod of 1 minus h lambda should be greater than equals to 1, right? This inequality also can be written as this. So 1 minus now see 1 minus h lambda is greater than equals to 1 only for negative values of lambda, क्योंकि लैम्डा अगर नेगेटिव, बिकॉज h तो हमेशा पॉजिटिव होता है, अगर लैम्डा नेगेटिव हुआ तभी 1 से ग्रेटर वैल्यू देगा. तो यहाँ से ये तो पता चल गया कि फॉर द गिवन इनिशियल वैल्यू प्रॉब्लम the given initial value problem gives a stable solution only for the negative values of lambda. ठीक है, we will see is there any condition on h which makes the given solution stable. तो देखो h की वैल्यू आप कुछ भी ले लो, you can take arbitrary h. This quantity is always stable because हमने lambda को negative बता दिया, तो this quantity becomes positive. If this is positive and this is always greater than 1, 1 minus h lambda is always greater than 1. So 1 upon something which is greater than 1 is always less than 1. So that is why for arbitrary choice of h, here h is arbitrary. So that is why we can say there is no condition here on h which makes the given backward Euler as a stable. So backward Euler is unconditionally stable but the forward Euler is conditionally stable. ठीक है? So this was the stability of the backward and the forward Euler method. Now we will see a question. कुछ भी प्रॉब्लम हो नेक्स्ट क्लास में भी आप लोग पूछ लेना, अभी तो जस्ट या फिर अभी किसी को पूछना है तो पूछ सकता है. जो इसके नोट्स है वो मैं आपको सेंड कर दूंगी, तो उसमें कुछ भी प्रॉब्लम या कुछ डाउट आता है तो यू कैन आस्क मी इन द नेक्स्ट क्लास. So let us now see our first assignment question. I don't know in which assignment it is given, but let us pick randomly. So we will try to solve initial value problem using backward Euler method. Because forward Euler से तो I guess जितने भी questions assignment में दे रखे हैं आप लोग वो सारे कर लेना forward Euler से related for different step sizes. जैसे कुछ क्वेश्चंस ऐसे हैं जिसमें आपको डिफरेंट स्टेप साइजेस के लिए फॉरवर्ड आइलर से सॉल्यूशन फाइंड आउट करना है. So what you will do in that case, you just try to find out the solution for different time steps, and then what you will do, you just compare कि अगर मेरा स्टेप साइज इंक्रीज हो रहा है या रिड्यूस हो रहा है तो what changes we will see in the solution. ठीक है, तो इस टाइप का कंपैरिजन करके देखना. ऑब्वियसली यू ऑल नो दैट एज द स्टेप साइजेस डिक्रीजेस वी विल गेट द बेटर सॉल्यूशन, क्योंकि वो मोर अप्रोक्सीमेट होता है एग्जैक्टली तरफ. अगर हमारा स्टेप साइजेस छोटा है तो यू कैन ऑल्सो सी द सेम थिंग बाय डूइंग न्यूमेरिकल प्रोसेस. ठीक है, सो लेट अस सी आवर फर्स्ट क्वेश्चन. y dash is equals to minus of y square and initial condition is given by y1 is equals to 1. We will use the backward Euler method. Okay, and it is yn plus 1 is equals to yn plus h times of, here h is 0.1. Okay, okay, and f of t n plus 1 comma y of n plus 1. So it is equals to yn plus h times of minus of yn plus 1 square. Here ft comma y is this. So it is equals to yn minus h times of yn plus 1 square. ठीक है, this is our equation number 1. अब यहाँ से करना क्या है, for different choice of n, different iteration अपन को find out करने हैं. और y0 की वैल्यू तो पता ही, y1 y2 y3 की वैल्यूज कैलकुलेट करनी है. तो यहाँ पे जो वैल्यू आपको फाइंड आउट करनी है, which is क्वेश्चन में लिख देती हूँ, we have to find the value of y at 1.2, यानी कि अप टू 2 आइट्रेशन तक अपन को फाइंड आउट करना है, क्योंकि 0.1 0.1 is our step size. तो फर्स्ट आइट्रेशन से अपन को y1 की वैल्यू तो पता ही, y1.1 की वैल्यू मिलेगी, और सेकंड आइट्रेशन से y1.2 की वैल्यू मिलेगी. सो वी विल गो अप टू सेकंड आइट्रेशन ओनली. तो बट उसके लिए हमें, जैसे अगर हम सपोज यहाँ पे n इक्वल्स टू 0 सब्सटीट्यूट करते तो y0 की वैल्यू तो पता है. अब y1 जो आएगी एक नॉन लीनियर इक्वेशन आएगी. तो उस नॉन लीनियर इक्वेशन के लिए वी विल यूज न्यूटन रैप्सन मेथड. ठीक है, नॉन लीनियर इक्वेशन को सॉल्व करने के लिए वी विल यूज न्यूटन रैप्सन मेथड. सो व्हाट आई डू हियर, आई कैन write that this is an implicit equation. This is an implicit equation in terms of yn plus 1, and it can be solved by using an iterative method which is Newton-Raphson method. Okay. Newton-Raphson method की help से we will try to find out the value of y for the first iteration. देखते हैं कैसे करेंगे इसको. So let us write